everyone, and welcome to Activity 26. Today we are going to talk about parabolas and how they are kind of the first new-ish, because we have talked about parabolas before, of our conic sections. And this starts on page 347 in your Springboard book, and it talks about Rosa being shot from a cannon. There's a human cannonball. So if you think about the trajectory of someone who is being shot out of a cannon, they're going up, out, and back down, right? So we see this concave down parabola, right? If you think, about the shapes that we know would be looking like a parabola like this. And parabolas aren't new information to us because we've talked about them before this year back in Unit 2 when we talk about having, y equals x squared would be a parabola, or in this case, a downward facing is negative x squared, or if we have a left and rightward facing one, that's when it's x equals y squared, or negative y squared for left facing. So we've talked about parabolas before, but now we're more so going to be talking about them with respect to being a conic section. Now, what is a conic section? This is on page 348. And basically what conic sections are is if we slice a cone that is on top of another cone, which I believe, I feel like they call something special, like a double something cone somewhere. In this intersection, they talk about, double napped right cone, there it is. We see that we have our four conic sections. So we've talked about circles already, and that's when we cut here versus the parabola, and we kind of cut sideways. And then we'll also talk about ellipses that kind of look like our ovals because we're kind of cutting on an angle. On the hyperbolas, which are like parabolas, but we're cutting like perpendicular to the base. So these are our conic sections. And again, our first one we're going to talk about is our parabola. Now, parabolas are formed from a fixed point on a fixed line, and we have a focus and a directrix as a part of each of them. So we'll see that at the bottom of page 348 for our upward facing traditional parabola that we're used to talking about, y equals x squared. And when we see this, we see the points on here. There's the parabola itself, and then it's always focused towards the focus. It always will open towards the focus and then away from this directrix line here that we have going on. And it's the same distance, however, there's this distance away from the vertex that's the same value for both the focus and the directrix. There's this value in between here, and it'll be that same distance away, okay? Now, there's also the axis of symmetry that our parabola is going to open up on. It doesn't talk about that in here, but we have the axis of symmetry, okay? And then compared, again, to the directrix, in this case, this would be a vertical line through 0 versus our horizontal line that is through the value here of whatever this d-value distance from the vertex of the parabola is, okay? And again, we know this is going to be an x squared parabola because of, again, the opening upward nature. It would be negative x squared if it was opening downward on that. So that talks a lot about our parabolas. Now, the rest of 26.1 really will talk about inverse, and again, reviewing some stuff that we talked about back in Unit 2, but that we're not going to focus on as much now, okay? One question I do want to talk about before we move on to the next part of this is number 29 on page 352. And that's in the check your understanding box. And we talk about a parabola that is facing upwards. So imagine you drew a parabola that is opening upwards, and it says that the vertex is at 3, 4, and the focus is at 3, 6. And they want the equation of the directrix line that in this case would have to be like this. Well, we talked about earlier that there's this same distance between the vertex and the focus and the vertex and the directrix. And in this case, it's going to be 2 since we went from 3, 4 to 3, 6. That means it would also have to be a 2-unit difference to be down here. So what's happening is it's actually going through the y value of 2, y equals 2 would be the equation of that line there. Okay, so we kind of start working with those. Now, some more work with our parabolas is going to continue on in lesson 26 too. So this is moving on page 353. And on page 353, we see another parabola given. And we also are finally seeing the standard forms for both our vertical upward and downward facing parabolas and our horizontal left and rightward facing parabolas. Okay, and these are definitely some information you are going to want to write down. Now, similar to our circles, h comma k is the vertex, though, of our parabolas as opposed to the center of the circle. Again, we've talked a little bit about this little distance value. It's going to be the same from your vertex to your focus and your vertex to your directrix. And then for our up and downward facing parabolas, y equals whatever number is your directrix, because it's a horizontal line. That would change for the left and right facing parabolas, because it would have to be a vertical line. And then a reminder that out front here, if you have a positive value, it's going to open up. Negative value opens down for x squared. For y squared, it's the opposite. You have negative means left, positive means right. Okay, so plus means right, negative with left. So in this particular problem, we know that the coordinates of our focus would have to be, in this case, above our vertex. So it would be whatever the vertex value is, and then we would have to add d units to our y value to figure out the distance above. And then similar to that last problem we talked about, we would have to move that many d units below whatever our k value is, and it would be y equals, because our directrix is a line. Okay, so again, kind of visualizing is always helpful, or using these formulas. Now, moving on from there, we want to get in the habit of identifying these pieces of information and being able to sketch our own graphs of these pieces of information. So for this first one, they give us an example on page 354 of a graph here. We have the parabola, and from there we want to identify the pieces of information. Now remember here that this is equal to 1 over 4d. To get that distance between our vertex and our focus, and our vertex and directrix, we need to solve this proportion. So that's where finding out that our d value is 1/2 will help us move left and right to figure these out for this horizontal facing parabola. Okay, so I would recommend graphing these in the My Notes section, which you should have enough room for both A and B on there. Okay, so the first one in example A, it's in standard form, and we know this is an up-down facing parabola because the x is squared, and in fact we know it's going to be opening up because this is a positive value out front. Now our value for d, if we solve this, 1 over 4d equals 1/4 this time, which means if we cross multiply and solve, we end up with 4d times 1 equals 4 times 1. So our d value is 1 this time. And our vertex is at 3, 2. So I'm going to graph 3, 2. I'm just drawing my own coordinate plane. I'm going to go to the right 3 and up 2. This is my vertex. And again, I'm an upward facing vertex this time. So I know that my focus, since I'm facing upwards, is going to be 1 unit, this distance value above my vertex. Here's my focus. And I know my directrix is coming the same amount below. So it's going to be a horizontal line below. And then my parabola, again, opens upwards, like so. We'll just sketch this in. So our focus would be 1 unit above at 3, 3. Directrix is a horizontal line through +1. Now in the second example, this one is going to be a rightward facing parabola because we have a positive value out front, and since it's y that's squared, we knew it had to either open left or right, again in this case right. And our vertex this time, you want to be careful. Here is your H, here is your K. So we're at -1, comma, -3 here, okay? H always goes with X, Y, K always goes with Y. So be careful of where that is placed, as they will flip-flop, unlike over here where we had H, comma, K, X, and Y. So our value for D is going to be found by setting these equal. So in this case, we end up with 4D equals 8. So D is 2 this time. And so when we graph, we're at -1, -3. And again, we are opening to the right. So our focus will come 2 units to the right. Okay, so here's our focus. And then our directrix this time will have to be a vertical line away and open to that right value. Just sketch this in. So the focus was at +1, -3. Directrix would be an x equals value since it's a vertical line and it's through -3. Okay. Now, both of these, also asked for, would be potentially asking for the axis of symmetry. On this one, the axis of symmetry would be a vertical line through our value of 3. But in the second one, our axis of symmetry would be a horizontal line through -3. Okay, so again, axis of symmetry is where we would fold over our parabola potentially to get them equal to each other. Now, sometimes you are not going to get your answer necessarily in standard form, and that's where example B comes into play, where we are going to want to be able to use completing the square in order to rearrange this so that this is in our standard form, okay? Now, notice on this one, we end up with a -y value, so that's why we see that we have like this opening leftward facing parabola. Okay, so if we look on page 255, we are going to see here some more examples that they don't give you a crazy amount of room for, but we will we'll go through. So let's look actually at example B to start here. And this time, as we've said before, when we complete the square, you want to arrange this so that you have your squared terms together. And then this time, we not only want the constant on the other side, we want the unsquared term. So in this case, this -6y also is going to have to move to the other side. So we're going to add, 6x and subtract 13 to the other side. But we will be completing the square here, so we're going to add a blank to both sides on this. Now, divide by 2 and then square that value to see what we're adding to both sides. We're going to end up adding 1 to both sides. So we end up with y plus 1 quantity squared when we factor on the left, and then 6x minus 12 when we factor on the right. Okay, now be careful here. We have a GCF involved here where we could take out this 6 and be left with x minus 2 in parentheses. And then last but not least, we're used to having, when we look at our standard form here, we want this 1 over 4d value with our squared variable for both x squared and y squared. And as we currently have it in our example here, it's with the non-squared term. So the last thing is going to be dividing this over to the other side so that our final answer, let's rearrange this so that the x's are on one side. We have x minus 2 over here, and then 1/6 y plus 1 quantity squared. This would be our standard form. Now from here, we can find the vertex as we did before. We have h and we have k, so +2, -1. We can also then find our focus, our vertex, and our axis of symmetry, because we would be at 2, -1 for our vertex, and 1 over 4d has to equal 1/6 this time. So when we cross multiply, we end up with 4d equals 6. D is going to be 6 divided by 4, or 3/2, aka 1.5. Okay, so this one had a positive value, so we know we're opening to the right, and we would be moving to the right 1.5 from our vertex. So that's 3.5, or 7/2, comma -1. And then we also would want to move to the left 1.5 to get our directrix. So that would be 1/2, or 0.5. Directrix is a vertical line, so that would be x equals 0.5, or 1/2. And last but not least, axis of symmetry on this one is through y equals -1. So a quick sketch even can help you identify these points as needed. Okay, last little bit here. We have, for example C, talking about finding and writing our own equations based on some given points. I highly, highly, highly recommend you to draw a picture. Okay, it's going to make your life so much simpler if you just sketch a short picture. What I mean by that, for part A, if we have a focus at 7, -1, so right here would be our focus, our vertex is at 2, -1. Well, remember, we always started our vertex and open towards our focus. So in this case, this is a rightward opening equation, so we know this is y equals x squared, and it's going to be, y squared, because we're opening to the right. So the y value would be squared, and it's positive out front because we know it's opening that way. Now, the other thing is we know the distance between these 2 points is 5 units. To get from 2 to 7, we had to move to the right 5. So as we start plugging this in, again, we know it's going to be x minus h, 1 over 4d, and then y minus k quantity squared. Well, we have h and k are 2 and -1, and then our d value is 5. So our final answer here, x minus 2 equals 1 over 20, y plus 1 quantity squared. Same thing then for part B. We have h and k given, and in this case we're at 3, 2. This time our focus is at 3, 0. So again, vertex always opens towards the focus. It's a downward facing, so we know it's a negative x squared type of parabola. So y minus k is -1 over 4d, x minus h quantity squared. And from here, we have our vertex h and k, 3 and 2. And our distance, we had to move to get from 2 to 0. Our d value is 2 units, and we already accounted for the negative out front here. So when we simplify, we have y minus 2 equals -1/8 x minus 3 quantity squared. Okay, now a lot of information about parabolas there that we will definitely work more with in class and in tomorrow's lesson. Thank you so much for watching. I'll see you in class.